Now we're going to take up one more problem on projections of points. The 2 points capital R and S, capital S are on HP. The point R is 35 mm in front of VP, while capital S is 50 mm behind VP. The line joining the top views makes an angle of 40 degrees with XY line. Find the horizontal distance between the projectors. So here, first we will going to draw the XY line, and then the 2 points capital R and S are on HP. So first we are going to consider the point capital R. Since R is on HP, obviously the image will going to fall on VP. So since the image is on VP, obviously it will going to be the front view. So consider any point on XY line and you mark that point as R dash. And 35 mm in front of VP. In front of VP is always seen in HP. So draw a vertical projector below the XY line. In front of VP is always comes below XY line. So since the image is on in front of VP, the image is on HP. So obviously that will going to be the top view. So you mark that point as R. Then draw a horizontal line here. Then while S is 50 mm behind VP, so behind VP will always comes above XY line. So from XY line you measure 50 mm and draw a horizontal line. So it will going to be the locus of S. So because we don't know where exactly the top view of the point will going to lie, because S is 50 mm behind VP is always seen in HP. So since the image is on HP, so obviously that is the top view. But the line joining the top views makes an angle of 40 degrees with XY line. So this is the top view here. We know from here you measure an angle of 40 degrees by using the protractor and then draw a line so that it will going to cut this locus here. So you're going to get this point as S. But S is on HP, so S is always comes on XY line. So you draw a vertical projector from here and you cut to the joint to the XY line and you mark that point as S dash. Then you measure the distance from R dash to S dash. So the horizontal distance between the projectors, that is between this line and this line, the L will be equal to 101.30 mm. So this is how we will be able to solve this problem manually, and also this is the concept. Now we will going to try to solve the problem using the Autocad software. So first we'll go to the Autocad screen, switch off the grid mode and switch on the ortho mode. So now the command is limits, lower left corner 0, 0, upper right corner 297, 210. Then zoom all. Then go to line, select some arbitrary point and click on first button of the mouse and drag the cursor to the right side, take some distance, and again you click on the first button of the mouse. And again you drag the mouse to the top side, take some distance and click on first button of the mouse and then go to offset. Now what we will do is we are going to draw the A4 size sheet. So you are going to take 297. So select this vertical line and offset to the left side. Again go to the offset, take the distance as 210. Take the distance as 210, enter, select this horizontal line and offset to the top side now. Then go to zoom, extends and zoom 0.6x. Then go to fillet between this vertical line and this horizontal line. Similarly between this horizontal and this vertical, and similarly between this vertical and this horizontal. Then go to zoom window, then go to dtext. So that problem number 35, 2 points capital R and capital S is on HP. So go to dtext, specify start point, take some point and take the height as 4. Problem number 35, 2 points R and S are on HP, capital R and S on HP. Then the point capital R, 2 points are on HP, 2 points R and S are on HP, Then the point R is 35 mm in front of VP. The point capital R is 35 mm in front of VP, while S is 50 mm behind VP, while capital S is 50 mm behind VP. The line joining their top views, the line joining their top views makes an angle of 45 degree, I think 40 degree. Line joining their top views makes an angle of 40 degree with XY. Then find the horizontal distance between the two projectors. Find the horizontal distance between the projectors, between the two projectors, between the two projectors. Full stop. So now this is the problem. Now we want to solve this problem. So go to zoom window again and take it nearer to the screen. So now we are going to solve this problem now. So to do that, first we'll go for layer command. Click on new, type the layer by name XY, enter, click on new, type it as front view, and then click on new, type the layer by name top view. So now set the line weights 0.05, that is the line thickness. Layer XY, you are going to get 0.13. Of course, you will not be able to see that much difference in the screen, but when you are taking it to the printout, you will going to get the clear, you can see the distinction. Then the front view will going to be the magenta color and the top view will going to be of the red color, and say OK and then close it. Now we will going to draw a line of some arbitrary distance. Then go to line. So first what we need to do is we want to draw a vertical line below the XY line. So go to line, take nearest point and draw one vertical line here of some distance, and go to offset 35 mm in front of VP. So you take this offset 35 and then go to trim this line, object to trim as this, and then go to erase. So here what we will do is you just go to fillet, keep some distance, then go to break. So I will just have some line contact, because that I need to measure that distance when you want to give it to the dimensioning. So then it says offset 50 mm behind VP. So behind VP will always comes above XY line. So from here you take offset distance. Then the line, so this is the top view line, so which will going to lie, so that will going to be the locus of S, what we need to write. So we will going to write it at later stage. So then go to line, take int of this. So I will take some distance, arbitrary distance, at the rate I will say 200 less than, at the rate 200. So first I will go for a line command, take intersection point of this and say at the rate 200 less than 40 degrees. So here we will go to get this, then go to trim, select this as the cutting edge, this as the object to trim, and then go to line, take int of this and draw perpendicular to this. So you will go to get this point here. So then break this line till here, and similarly you break this line till here. So we got the answer. So this is how we will be able to solve this problem, but of course we need to write all other things. So to do that, so first we will go for this. So r dash, yes, so we're going to write that. So first we'll go to the donut, make it 0 and make it 3, and take int of this and take int of this, and here you take int of this and take int of this. So now here you break this, and similarly you break this line till here. Then go to d text. So you mark this as, go to d text, you mark this point as 3, rotation angle as 0, you mark this as xy, and then here r dash or s dash s. So you will just go to r dash and then r, then here s dash, and here it is s, and here you type locus of s. locus of S. So now you just go to move and move these points or the text appropriately. Then we have S here. Then this will going to be the locus of S. Then go to DDIM. Then go to modify. Then go to lines, make it 2. And then symbols and arrows. Take the arrow size as 3. Text as 3. Then align with the dimension line. Centered becomes above. So this will going to be 2. Then go to primary units. Make this as 0 and say OK and say close. Then go to dim, take center of this. So first we are going to change the line thicknesses now. Go to CH. So go to layer, make this layer as XY. Then you take the front view and change that layer to front view. So accordingly this will going to change. So you take this and you take this. So go to CH. So go to CH and also include this CH. Go to layer, make that layer as top view. So locus of S. Now we will go for dim. Take center of this and you take center of this. So you take center of this. So you're going to get 35. Then you take center of this and you take center of this. Obviously the distance will be 50. And first you need to give the angle. So go to angular dimension, select this line and you select this line. So you're going to get it as 40 degrees. Then go to center of this and take center of this. So here you go to text, give space and enter and you place it wherever you want. So then go to dtext. So go to dtext. So here you mark this as L equals question mark. L equals question mark. So now we need to write the answer. So we need to check the dimension or check the distance between the front views. So you take center of this and you take center of this. It will be 101.3. So that is what we want to get here. L is equal to 101.30. So go to dtext. So go to answer. So go to dtext. So here type L equals 101.30, 101.30 mm. So now L equals, so here put the ortho mode. So you take this dimension and then go to fillet between these two. Then go to move, switch off the ortho mode. So you place it wherever you want. So this is how you will be able to solve this problem by using AutoCAD software. So this will looks more or less same thing, exactly the same as this. So this is how you will be able to solve this problem. And now whatever the problem we have done in the CAD software is also right. Thank you.